Now you've had a chance to look at some graphs of sine and cosine functions. We're going to talk about some characteristics of these graphs. And the first thing we're going to talk about is the amplitude. And what you probably noticed doing this last assignment is that when you put a coefficient in front of the sine or the cosine, that affects the height of the wave. It makes it taller or shorter. So for example, if we were to take sine of x and make it, say, 3 sine of x, that would get 3 times taller. Now, the way you measure the amplitude is from the middle of the wave to its peak. So on a standard sine or cosine wave, like this green wave on the bottom here is a cosine wave, you would start in the middle, which is the x-axis, and then you would measure it to its peak, which is at the 1. So it would have an amplitude of 1. And you'll notice the formula, I guess, for amplitude right here is the absolute value of A. So let's look at that really quick. I'll pull up Desmos. Here's your standard sine function, sine of x. So if we multiply this by 3, all of a sudden our amplitude goes from 1 to 3. So now the amplitude, if we measure it from the middle to the top, is at 3. But if we did a negative 3, it flips the graph, but the amplitude remains the same. It's still the measurement from the middle to the top is going to be 3. So that's why amplitude is an absolute value. The other thing to look at really quick, and you probably noticed this on the most recent assignment, is say you take a number whose absolute value is less than 1. So let's do like 1/2. There, instead of making the wave taller, it shrinks it, it crunches it. And again, you can look at this coefficient to find the amplitude. The amplitude here would be 1/2. And you can see from the middle of the wave to the top is going to be 0.5. So amplitude is determined by this number on the outside, this coefficient in front of the sine or the cosine. And it's always going to be the absolute value of that number. All right, so amplitude is a vertical measurement. It measures height. The next one, period, measures it's a horizontal. It measures the length or the width of the cycle. So period is how long does it take your wave to go through one full cycle. And on a standard sine or cosine wave, your period is going to be 2 pi. So if you look again at the cosine wave, the green one on this picture, the best way to measure the period is to start at one peak and to follow the wave until you get back to that peak. And you'll see we go from 0 to 2 pi. So from where x is 0 to where x is 2 pi. So the length of one full cycle of that wave is 2 pi. And that makes sense because if you remember, everything here is based on the unit circle. 2 pi is the distance all the way around the unit circle. So when you go from 0 to 2 pi, you're running through all your possible sines and cosines, and then you get back to where you started and you do it again. Now, the way you would change the period of a wave is by multiplying the variable by something. So let's say, for example, I multiplied this x by 8. And actually, let's go ahead and look at this on Desmos so you can see what happens. When I multiply that variable, what I'm doing is I'm multiplying my angle measurements. So if I multiply it by a number bigger than 1, like 8, what I'm telling this to do is to run through the cycle faster, because you're going to have the numbers here on the inside that you're taking the sine or the cosine of are going to get bigger faster. So you're going to go from 0 to 2 pi a lot more quickly. And so you'll get something like this, where the wave has a greater frequency, where the period is much shorter, and the wave is more crunched horizontally. So the period is kind of an inverse measurement. As this number gets larger, the period gets smaller. And if you had a small number on the inside, like let's say 1/3, that gives you a much longer period. It stretches the wave out horizontally. Because if you multiply that number by something less than 1, it's going to cycle through all the angle measurements more slowly. It's going to take it a lot longer to get all the way around. So that's what affects the period. And the way you would calculate the period using the equation is with this little formula, 2 pi over b. So I wrote 8 here as the coefficient for x. So to find the period, if we had an 8 in front of the x, we would take 2 pi over 8. And then we simplify it. We get pi over 4. So the period of this function will be pi over 4. And let me just one more time go back to the graph. I said one more time. We're going to be looking at this more than once. But when I had this 8 here, you can see that from the beginning of this wave all the way up, all the way down, back to the beginning, goes from 0 to pi over 4. And it might be easier to see that with a cosine function because then you start at the top and you can see from this peak to the next peak is exactly pi over 4. So that's how you find the period. All right, the third one is phase shift. And so that has to do with the number that we add or subtract from the variable. So that would be the c here. And so again, let me just alter this. And I'm going to say, let's do 8 and then x minus pi over 3. So when I put something in there, it's going to move my graph to the left or the right by that amount. But the thing about it, you'll notice here, the formula says negative that number. So it's always going to do the opposite. If I put in a minus pi over 3 like I did here, the phase shift is going to be positive 5 over 3. It's going to move it pi over 3 to the right. If I were to do a plus pi over 3 or a plus something, it would move it that much to the left. This is a little harder to see on Desmos, but let's give it a try. So I'm gonna do cosine instead of sine. Here's our standard cosine function. If I add, let's do pi over 3. If I add pi over 3, you'll notice instead of starting at the top, it starts at negative pi over 3. So it moved pi over 3 to the left. So it goes in the opposite direction of what the sign says, which is something we've seen with other types of functions. Let's change the sign here and make it minus, and it's going to move it that far this time to the right. So it starts at positive pi over 3. So phase shift moves it left and right, and it's always the opposite of whatever that number is. All right, so I want to do some examples. So I'm going to go to the PowerPoint here. And so here it says find the amplitude and the period of the function and sketch the graph. So let's give this a go. So I'm going to do 18 and 20. And actually, really quick let's do 18 one more time before I get into this example. I want to look at one other thing because you'll notice we do have a negative on 18 in front of the sign. So let's look at that really quick. Let's look at what that negative does. So back to Desmos. So I'm just going to go, let's just keep our standard cosine function. Actually, we'll keep the phase shift. Let's just see when we do a negative, what happens to it. So when we do a negative, and we saw this with the amplitude earlier, it flips the graph. So your standard cosine function, let's get rid of the phase shift so we can see this better. Your standard cosine function starts at the top. It starts at positive 1 when x is 0. So if you make it negative, then it starts at the bottom at negative 1. So a negative sign just flips your wave. So that's going to be important for graphing this first one. So we've got a negative sign of 2x. And before we graph it, we want to find the amplitude and period. So for 18, our amplitude is the absolute value of that coefficient. So we have a negative, that would be like a negative 1. So it's going to be absolute value of negative 1. So the amplitude is going to be 1. So the peak is going to be 1, and the lowest point is going to be negative 1. The period for number 18, period is 2 pi over this number right here, the number multiplied by the x. So it's going to be 2 pi over 2. So the period is going to be pi. So here's how we graph it. And we've got this handy thing over here. Sine on this graph is the red one. And if you look at a standard sine function, it starts at 0, 0. And we have not phase shifted, so we're still going to start at 0, 0. That will not be affected by the negative. A standard sine function has a period of 2 pi. So it takes from 0 to 2 pi to run through one full cycle. This has a period of pi. So we know once we get to pi, we are going to be right back where we started. I'm going to go ahead and say this is 1 and this is -1. So we're going to start at 0. We're going to run through one full cycle. We'll end up back at pi. So our amplitude is 1. So we're going to go up to 1. We're going to go down to -1. So that's going to be where our peaks and valleys are. Here's the last thing we need to look at before we graph this. On a standard sine wave, we start at 0, 0. We go up, then we go back down, and then we go up again. If it's negative, we're going to do everything the opposite. So we're going to go down, up, and then back down again. So what we'll do for this is we're going to go down to -1. We'll go back up, we'll hit +1, and then we'll end up at pi. So what we'll do here is we know we're going to be, when we get halfway through the wave, we will be right here halfway along our period. So we're going to go down, up, up, down. So we're going to go like this. All right, so that's what the graph is going to look like. And then it's just going to repeat that pattern. It's going to go down, up, and down again. And so we can go this way too. And then you don't really need to do more than that unless you really want to. All right, let's go ahead and do the number 20, the cosine. So here we have a 1/2. That's going to affect our amplitude. Let me do this in a different color so we can see it. So cosine on this picture in the corner is green, so I'll do green also. All right, so 1/2 cosine of 4x. So our amplitude is going to be the absolute value of 1/2, which is just 1/2. And what that means is instead of going up to 1 and down to -1, we will just go up to 1/2 and down to -1/2. So it's going to be half as tall as a regular wave. Our period, we use that 4, and we do 2 pi over 4. And when we simplify that, we get pi over 2. So what this means is this wave will run through one full cycle from the time it takes to get from 0 to pi over 2. So let's look at this. Cosine starts at the top. So normally we would start up at 1, but because our amplitude is 1/2, we're going to start at 1/2 because we're shorter. It will take to pi over 2 to run through one full cycle. So we will go all the way down and all the way back up to get to pi over 2. So what we know is our cosine, if you look at your wave here, your lowest, the place where you hit the bottom is going to be halfway in between two peaks. So we're going to say halfway in between, we're going to hit the bottom. And so we're going to go down and back up. And then we'll just continue this. Down, back up, down. It's not very good, but you get the point. Back up. So that's what it's going to look like. It's going to, every time you go pi over 2 in either direction, it's going to go back up and hit the top. So that's what the cosine wave will look like. So do your best with these graphs. These are tricky. They're hard to visualize. Take a stab at it. If you don't get it right away, don't worry about it too much. Also, feel free to use Desmos, or if you have a graphing calculator, to check your work and see if you did it correctly. See if their graph matches yours. And if it didn't, try to figure out what you might need to do differently. I want you to make sure you can find the amplitude and the period. If you struggle with the graphing part, that's okay, because that's really tricky and that might take some time. But make sure you're okay finding your amplitude and your period and your phase shift, which is what we're going to do here. So I gave you a couple of problems like this, and for this part, you don't need to do the graph because you will do enough graphing on the other ones. So I just want you to find the amplitude, the period, and the phase shift. And we're going to do two examples, 30 and 32. So on 30, our amplitude equals, we use this 2. That's our coefficient. We take its absolute value, and so it's just going to be 2. Our period, remember, that's 2 pi over the coefficient on the variable. And if you look here, there's no coefficient. So that would just be a 1. So our period is just 2 pi over 1. So our period is just going to be 2 pi. It's not going to change. And that happens a lot. That's okay. So it'll just be 2 pi. Our phase shift is going to be determined by this number that we're adding or subtracting from the variable. And remember, all you have to do for your phase shift is change the sign. So if we're subtracting a pi over 3, our phase shift is going to be positive pi over 3. It's going to move pi over 3 in the positive direction. So this isn't really too bad. Just you're just finding these 3 things. You just have to kind of keep the formula straight. Let's go ahead and do number 32 also. So our amplitude on number 32 is just going to be the absolute value of 3. And maybe I should have found some trickier examples. These are all pretty straightforward. Your period is going to be the exact same thing it is on 30. Your coefficient is a 1. You don't have anything you're multiplying your variable by. So it's 2 pi over 1, which is just 2 pi. And then your phase shift, you have a positive, a plus pi over 4, so it's going to become a negative pi over 4. It would shift pi over 4 to the left. So that's all you need to do on this sort of problem. Find the absolute value of the coefficient in front of sine or cosine. If you have a coefficient in front of the variable or in front of the parentheses containing the variable, it'll be 2 pi divided by that number to get the period. Your phase shift is just whatever's being added or subtracted from the variable, and you just change its sign. Last thing to do here, and this could be tricky, but you're not going to have to do too many of these, is you have to come up with an equation to match the graph. And so here's what I would say first. I'll just write this off to the side. If you have a graph that starts at 0, so it starts at 0, 0, or it starts in the middle, that's going to be a sine function. Now, I say this with a caveat. For any sine function, you could come up with a cosine function that would look exactly the same. So you could take a cosine function, shift it, and it would match perfectly with the sine function. But for the sake of finding one equation and trying to find the most simple equation to match a graph, this is what I would look at. If it starts in the middle, so like 43 and 46 are what I'm talking about. They start in the middle. They start at 0, 0. So when you're in the middle of the graph, you're in the middle of the wave. Cosine is what you would use if you start at the top or the bottom. So if I was going to do all 4 of these problems, and I'm just going to look at the 2 even numbered ones, but for 43, I would use a sine function. For 44, I would use a cosine because it starts at the top. 45 is another cosine. 46 would be a sine. So we're going to look at 44 and 46. So 44, I just said we're going to use cosine because we start at the top. And I'm just going to start with cosine of x. And then we're going to look and see what do we need to do with it. Well, first thing that I notice about this is the peak is at where x is equal to 0. If your peak is where x is equal to 0, it has not been shifted. So we don't have to worry about a phase shift, which is really nice. And on the ones I assign you're not going to have to worry about a phase shift. So that's good. So now we have to look at how has it been stretched vertically, how has it been stretched horizontally. Well, the first thing I notice here is my amplitude is 2. My amplitude is 2. So that's going to be my coefficient that I'm going to put in front. And it's going to be a positive 2 because this is a standard cosine wave that starts at the top. If it started at the bottom, then we'd have to use a negative. Second thing I'm going to look at is my period. How has it been stretched horizontally? And looks here like my period is going to be pi. So if I look at this, this is pi over 4. So this second one would have to be pi over 2, 3 pi over 4, and then pi. So if my period is pi, I have to figure out what number goes in front of x to make that happen. So what you have to do is think 2 pi over what, and remember b was the letter we used there. 2 pi over what equals regular pi. So what would I divide 2 pi by to get pi? Well, I'd have to divide it by 2. So think about what number, if you divided 2 pi by that number, would give you the period you have here. So it's going to be 2 cosine of 2x. Okay, 46. This is going to be a sine function, so I'm going to start with sine of x. I'm going to look at my amplitude, and it goes up to 3. My amplitude is going to be 3, so I'm going to put a 3 here. Then I'm going to check, is this a standard sine graph, or is it a negative, a flipped version? Well, normally on sine, you start by going upward. So this is going to be positive. It has not been flipped, so we're going to keep it at positive 3. Now I look at the period. Well, it looks like the period here, one full cycle from 0 to the end of the cycle is 4 pi. So I have to think 2 pi divided by what equals 4 pi. And let's work that out on the side where we have more room. So to stretch a graph, to stretch it out so it has a longer period, you're going to have to divide by a number less than 1. But here's what you can do. I'm going to multiply this b by both sides. We're trying to figure out what number are we divided by. So I'm going to try to get that by itself. So I have 2 pi equals 4 pi times b. And remember, I'm using 4 pi because that is the length of the period on this graph. So now I can divide by 4 pi. Those cancel out. My pi's cancel out, and I get 1/2. So basically, this graph on 46, it's been stretched, so it's twice as long. And to do that, we would use the 1/2. We would divide 2 pi by 1/2. So we're going to put a 1/2 in front of this x. So it's 3 sine of 1/2 x. And again, this graphing part is tricky. So here's what I would say. I want you to try it. I want you to see what you come up with. Feel free to plug stuff into Desmos or a graphing calculator to check it. And if you can't quite get it, we will look at this some more and we will work on it. So for this assignment, make sure you can find the amplitude, the period, and the phase shift from an equation, and then do your best with the graphing part. So that is our next lesson here on sine and cosine.